Welcome back to some more geometry. Today we are talking about rotation. So rotation is, as we talked about before, is a turning or a move around a certain point, a fixed point. Now that fixed point, we call that the center of rotation. That center can be somewhere either inside the image or outside the image. Now as you go through the homework, it's going to ask you, hey, you're going to rotate this by a certain angle, and that's the distance in degrees in which the image will turn around the center. Now, most of your angles of rotation will be some sort of multiple 90, so 90, 180, 270, 360, and so on and so forth. But usually you look at the main three, 90, 180, and 360. So let's talk about the actual center rotation. When we talk about them being inside, we look about how this has to center inside the image and this has to center outside the image in which you're going to rotate. Now in math, when we say counterclockwise, that's for us is the correct direction to turn counterclockwise. Everything counterclockwise. Even the clocks turn clockwise, yes, they're called clocks, we're going backwards. That's why even when we label the quadrants here, this is quadrant 1, this is quadrant 2, this one down here is 3. Ooh, one more. There you go. Looks like 3 now. And this one's 4 over here. So that right there is the proper direction. So most of the time, even if they don't say counterclockwise, then it's understood to be counterclockwise. Now, when it changes, when it's clockwise, they'll throw in a negative number. So maybe when they say negative 90 degrees, that means that's a clockwise because it's going against the usual turn. But let's look at our problem. Right here, we're going to say, hey, we're going to rotate this 90 degrees counterclockwise. So that means with the center being inside of it, it just stays as it is and turns in this position right there. Boom. That's roughly, let me turn it a little bit. There you go. That's roughly 90 degrees right there. So it turns towards the 90 degree. Again, if it was originally pointing upwards, now it's pointing to the left. But let's talk about when the image is outside. This is a little bit more mathematical when looking at this. So as you can see, this particular point right here is 1, 2, 3 units to the right here. So when it rotates 90 degrees, it should be 3 units up. So then this one being 6 units up, this will be now 6 units up as well. 1, 2, 3. And then of course this is over 2 up, 1, 2, 3. This is the transformed image of the original one. So you should look at that. That's our 90 degrees. Now, as you look at right here, the same face of our image is facing the center. So it's kind of like a plane. So if it were to go down here, roughly, it should be bam, bam. That's rough drawing right there. But of course, it's kind of following that same pattern. It's almost like not a clock, but a plane flying around a certain center right here. You're still looking, it's always looking towards the same side at all points right here. So that's how the rotation will look like. Now there is, when we're rotating around the image, so it's a rotation the coordinate, when rotations on a coordinate, I just forgot to say that word, coordinate plane, when we're looking at coordinate planes, when we look at these 90, 180, and 270 rotation little things, we are rotating, when we look at that, we're rotating around the origin right here. So we're going around the center. But think about it, every single one of these points will also rotate here. So as it's rotating around, not just that point right there, but then every single point on this line. We can almost think about it as a vector because every single one of these is going with it as well. So this point right here is 6, 3. So this will be the one we're going to use as our example here for all 3 of these. These are our quote-unquote formulas for this. So if you want to make sure you get these down for your test. So let's look at this rotation that's going to happen. When we rotate 90 degrees, we figured out that if you just take the original coordinates and you flip them, so now it'd be 3, 6, and then negate the first one. So since ours was positive and now it'd be negative, it will create a 90 degree rotation from the original image. So right here, the 6, 3 is not starting down here, so it won't end right here, but it's starting in this specific spot. So let's try this out. Let's kind of graph this and then draw it back to the origin. So we got 1, 2, 3, negative 3, and then up 6. 1, 2, 3, 4, 5, 6. Right there. That's our point. Let's connect it all together and see what happens. So if it's done right, it should look roughly about like a 90 degree angle to the center. Look at that. I would say that looks about 90 degrees. So we're good. All right, let's look at the next one right here. So now we're going to look at 180 degrees. speaking of the numbers right here, they will stay in their same spot. So it'll still be a 6 and a 3, but now we're going to negate both of them. So if this was a positive, since they are, ours would now be negative. But remember, if they were negative, they become positive. So we're looking at negative 6. 1, 2, 3, 4, 5, 6, and negative 3. 1, 2, 3, right there. So this particular point should make a 180 or a straight line, since we worked on that before priorly, to this image. Let's see, let's connect it all together. And we connect it to the origin. That looks roughly like 180 degrees, and also 90 to the previous image. Let's look at the next one right here, 270 degrees. So similar to the 90 degrees, we will flip the values. So it would now be 3, 6, but we're going to negate the second one, what's in the second position. So our 6, 3 now becomes 3, negative 6. So we go 1, 2, 3, negative 6, 1, 2, 3, 4, 5, 6. Right there. Let's connect it all and see if it looks 180 to 90 and looks like 90 to the original one. Look at that. Beautiful. Straight line right there, roughly a 90-degree angle right there. So congratulations, y'all. You learned how to do this. Now, we got 2 examples here that we're going to discuss. So let's look at this. So what happens where you rotate about the origin? So these are our coordinates right here that we're going to practice with. So we have J, which is at 3, negative 7, K, which is at 1, negative 1, and L, which is at 5, negative 3. Now we're doing a 270-degree rotation. 270 degrees. So I don't have these numbers. I'm going to go back and look real quick. So we're going to flip these and negate the second one. So let's kind of write that down. So we got XY will become Y, negative X. So this is the coordinates we have. So we're going to go ahead and flip them. So we will now have, we'll do this in purple. Let's go purple. So our new J prime will be at negative 7, negative 3. Again, we flipped it. We left the negatives negative because we're not messing with that. We're going to keep that at whatever it is. But we are negating what's in the old X value. That's the new Y value. So that means K prime should look like negative 1, negative 1. And then L prime should be what, class? Yeah, negative 3, negative 5. Let's graph that. So we got negative 7, 1, 2, 3, 4, 5, 6, 7, negative 3, 1, 2, 3 right there. We got negative 1 over here, and we got negative 3, negative 5, 1, 2, 3, 4, 5 right there. So let's connect them all together, and there you go. As you can see, it looks like it's pointing out that way, the way the image looks this way. So if it follows that same track all the way around, it should be pointing in the proper order. So that's rotating around the origin. But what happens if we are rotating not about the origin? But this time we're going to rotate about negative 5, 3. So let's kind of look at this right here. So our negative 5, 3 coordinate, negative 5, 1, 2, 3, 4, 5, negative 3, 1, 2, 3. This is going to be our new center per se. We're going to rotate around this. But here's the thing. We don't have necessarily what would you call a formula per se for rotating about something that's not the origin. So what are we going to do? So what we're going to do here, just to kind of look at this. We look at the vector, similar to like we said earlier, these have vectors almost back to the origin. We're going to look at the vector of this right here. So going from here to here, that is our vector back to the origin. So what we are going to do is we're going to shift all our numbers towards the center such that we can then use our little formulas up from the center. We're going to shift all these points. So we're going to get the way you're going to shift them is we're going to take, how do we go back to the origin? So in this case, to go back to the origin, we'll have to go positive 5, negative 3. So we're going to use the vector positive 5, negative 3. Now take a wild guess where these numbers came from. Yeah, how far we are away from the origin to begin with. So to go back, we're going to just reverse these numbers. We're going to go back 5 and then down 3 instead of the negative 5, positive 3. So when we do so, we will affect these numbers directly. Remember, vectors, they're added directly to the numbers. So our new A, and it's like a side quest A here, will become negative 3, 2. Then our B, our new temporary B, will be negative 1, 6. And our temporary C will be 2, 3. All right. Now, we're rotating 180 degrees. Now remember the formula for 180 degrees, they stay in the same position. We just change their values. So our A prime, we're going to go ahead and then keep the numbers the same, but we were to change their sign. So this will become now positive 3, negative 2. Our B prime will be positive 1, negative 6. And our C prime, negative 2, negative 2, negative 3. Just like that. All right, so we have these images shifted and then flipped over here, but we haven't rotated about that. So the way we're going to do, and it sounds kind of crazy, but what we're going to do now is we're going to reverse it back. We're going to slide all those points back over here. So I'm going to graph these points so we can see them, how they are before we put them back where they belong. So we're positive 3, 1, 2, 3, negative 2, positive 1, negative 6, 2, 3, 4, 5, 6, and then, of course, negative 2, negative 3. Okay, so definitely got reversed, but it got reversed around the center, not over here. So what we're going to do is we're going to shift these back. Now, to do so, we're going to go ahead and now reverse this. So we're going to go ahead and add the opposite vector back to these. So we're going to add negative 5, 3 to all three of this. So our final one, A prime, our true A prime, will be at negative 2, comma 1. Our B prime will be our new B prime. Our proper B prime, we'll say proper, will be negative 4, negative 3. And our C prime, the proper one, will be negative 7, 0. So all of these got shifted up 1, 2, 3, no, 4, 5, and then over to 1, 2, 3, 4. All right. So let's see what that looks like right there. We should have them at negative 2, 1 there. At negative 4, negative 3, 1, 2, 3. And then negative 7, 1, 2, 3, 4, 5, 6, 7, 0 right there. That looks like it's more properly rotated around there. So as complicated as it kind of sounds, it will work like that. Now, if we were to just leave these right here and never actually shift them, like if we were to just say, oh, we're going to just use a lot of people ask the question, why can't you just do 180 around around that point and call it good? And it's because that doesn't work from there. This is the proper location to rotate from. That's why we had to shift them down, rotate it, and shift them up. Because if we were to do that, we would have a positive 8, negative 5, and positive 8, negative 5 is down here. It did not rotate over here. So that's why we had to shift them down and then rotate them and then shift them back. So that's it, y'all. So hopefully that helps out. Y'all have a great day. Bye.